This video is on chemical nomenclature. Nomenclature is simply a name that means how we name things. So we're looking at the rules for naming compounds. Two learning targets in this unit here. We want to be able to write the formulas of ionic and binary nonmetal compounds, and then the opposite of that would be naming the ionic and binary nonmetal compounds. Just a couple of resources here for you. This is a different video from a different chemistry teacher on chemical nomenclature, and then this link here would take you to a page that has all sorts of different practice links on it. Take a moment here and read through the key ideas and definitions here for ionic compounds, and I would just pause the video and read through that, and then when you're done, pick up with the video again. Alright, so what you read there is some simple rules for naming ionic compounds. It's called the Stock system, named after a gentleman, I believe his name is Levi Stock. And the basic premise of naming any ionic compound is what's in bold here. It just simply says name the ionic compound. All it is the name of the cation followed by the name of the anion. The monatomic cations here, Group 1, Group 2, aluminum, zinc, and silver, all we need to do is give the name of the metal. The reason is those elements always have the exact same charge. We know Group 1 is always 1 plus. We know Group 2 is always 2 plus. Aluminum, as you've probably recognized in some examples already, is always going to be 3 plus. You might want to mark that on your periodic table. Same thing with zinc. You might want to mark this on your periodic table. It is always 2 plus. And silver is always 1 plus. I'll just jot those down there. 3 plus, 2 plus, 1 plus. Those never change. If it's any other metal other than Group 1, Group 2, aluminum, zinc, or silver, we have to indicate the charge after the name of the metal with a Roman numeral. And we'll see examples of how to do that. And then monatomic anions, we just drop the ending and add IDE like we've been doing for a while. And then polyatomic ions, just give the name of the ion. Alright, so let's jump down and do some examples with these, then we'll come back and read the second part here. Alright, so under example problems, it simply says name each compound. Well, the first one here would simply be aluminum oxide. Because aluminum, as we said up above, all I need to do is give the name of that. It's a monatomic ion of aluminum. And then oxygen, the monatomic anion of oxygen, we call it oxide. I know aluminum is always 3 plus, oxide is always 2 minus, so there's nothing else we need to indicate on here. Alright, next one, Ag is silver, and we saw above, all we need to do is say silver, because it's always the same charge. Silver is always 1 plus. Then NO3, you have to consult your polyatomic ion chart for that. You would see that that is named nitrate. So the name of this compound is silver nitrate. Alright, next one here, Mg is magnesium, and again that's in group 2, so all I need to do is say magnesium. And then OH, that would be a polyatomic ion. You need to look on your chart for that. That is the hydroxide ion, so the name of the compound is magnesium hydroxide. Alright, if you flip over to the back page, a few more examples with these ionic compounds. Here is the first example where we have an element that's not Group 1, Group 2, aluminum, zinc, or silver. Cu is copper. So we just go ahead and write copper. But then we need to put the charge of the ion in Roman numerals. And we put that inside parentheses. We'll come back and do that in just a second. I know the second part of the name is going to be chloride, because that would be the monatomic anion of chlorine, so that would be chloride. The question becomes, how do we know what the charge is? Well, we determine what the charge is by looking at the charge of the anion. I know that the chloride ion is 1 minus, and I can see that there's one of them in the formula, so the total negative charge is 1 minus. We've learned that the total charge on this whole thing has to be neutral, or no charge. So what that tells me then is the copper must be 1 plus. So the name of this is copper 1, with the Roman numeral 1 in parentheses, chloride. Again, the reason we knew that the copper was 1 plus is that's the charge that's needed in order to balance with the chloride charge. Alright, Next one here, we have Fe, that's iron, and again, iron is not group 1, group 2, aluminum, zinc, or silver, so I'm going to need to indicate the charge, so I'm going to leave space for that there. SO4, that's a polyatomic ion. Just look at your polyatomic ion chart. You'll see that that is sulfate. And then to figure out what the charge is on the iron, you have to look at the charge on the sulfate. We know sulfate from the chart, that is a 2- charge. Now remember, that is all just one ion. There's not 4 ions there, that's only one ion. And I can see we have just one iron, so the iron must be 2+ in order to balance with the sulfate. So this would be iron 2 sulfate would be the name of the compound. Alright, next one. We have SnO2. Sn is tin. And again, that would be one of those metals that we need to indicate the charge. So I'm going to leave a space for that. The O2 part, that would simply be oxide. That would simply be oxide. Now here we have 2 oxide ions. Each of them is a 2- charge. The reason I know we have 2 is I can see the subscript 2 here. But there's only one tin ion. Okay, again, there's no subscript behind tin, so I know that means there's one of them. So the total positive charge has to be 4+, because the total negative charge is 4-. So that tells me that the charge on the tin is 4+. So my formula then, or excuse me, my name of the compound is tin 4 oxide with 4 in Roman numerals. Recall that Roman numerals IV, that would be 4. Alright, these next examples here are for the binary nonmetals. We'll skip those and come back to them in a little bit. Alright, let's jump down to number 2 here, where it asks us to write the formula for each compound. So this is just the opposite of what we just did. Here we're given the name, and now we write the formula, which we've actually already done some of. The first one here, we have chromium 3 iodide. Recall that the Roman numeral tells us the charge. So what this tells us, the charge on the chromium ion is 3+. The iodide would be 1-. Okay, so here I would need 3 iodide ions to balance with that chromium 3 ion. So the formula would be CrI3. Alright, next one we have barium nitrate. Barium's in group 2, so that would always be 2+. Nitrite, look at your polyatomic ion chart, that is NO2-. I can see that I need 2 nitrite ions to balance with the barium, so this would be BaNO2 would be the formula for the compound. Here we have osmium 6 chromate. So the osmium is a 6+ charge. Chromate, that is CrO4 2-. So I would need 3 chromate ions to balance with the osmium 6 ions. That would be OS CrO4 3. And then here we have lithium bromide. Lithium's 1+, it's in group 1. Bromide, that's the monatomic anion of bromines, that's 1-, it's in group 17. So my formula is simply LiBr. Alright, these next examples go with the next set of rules. Alright, so if you flip back to the first page, and again, you might just want to pause the video here and take a second to read through these rules here. Alright, so you've read the rules, and what you've seen here is that we have to use these prefixes to show the number of atoms. The reason we have to do this for these binary nonmetal compounds is because there are no charges on them. We can't look at a charge and figure out how many of each we need to make the charges balance because there are no charges. Before we proceed with any examples, the term binary means 2, or 2 names. So what we mean by a binary nonmetal compound is compounds that are made of 2 nonmetal elements. So a question you might have had so far is, how do we distinguish or differentiate between the ionic compounds and these rules? And these rules, well, the easiest way to do it is simply to look here. If it's made of 2 elements that are both nonmetals, then we follow these rules here. And if it's not, then we follow the rules up on the top there. Alright, so let's go straight to the examples. And here we're naming the compound. We have NO. As you saw from your reading, the first element, we do not change the name. So this would just be nitrogen. The second element, we change the element name to an IDE ending. And there's one oxygen atom, so I need the prefix mono in front of it. So this would be nitrogen monoxide. Also note, it shows you in the rules there that if there's one of the first element, we don't include the prefix mono. If there's anything other than one atom, then we would put a prefix there. So if you look at this next example, we have 2 atoms of sulfur. The prefix for 2 is di. So I put disulfur would be the first word in the compound. And then I have 2 atoms of chlorine, so it would be dichloride. Alright, and then the last example we have here, P4, the prefix for 4 is tetra, so it would be tetraphosphorus. And then the prefix for 10 is deca, so it would be decoxide. You can see sometimes we'll drop the last letter, the last vowel in those prefixes if the element name also starts with a vowel, so you don't have those deca-oxide, you don't have those 2 vowels next to each other. Alright, so if we jump down to the next part here, writing the formulas for the compounds. Carbon monoxide, if it's carbon, that's just C then. There's no prefix, that means there's 1. Monoxide, that would be 1 atom of oxygen, so CO would be the formula. Phosphorus, there's no prefix in front of it, so that tells me that there's just 1 atom, so that would be P. Pentachloride, penta means 5. Chloride would be chlorine, so PCl5. Dinitrogen, here's the first time we have a prefix in front of the first element. Di means 2, so there are 2 nitrogen atoms, so N2. Tetroxide, tetra means 4, so 4 oxygen atoms, so N2O4. Boron, that's B, and there's no prefix in front of it, so just 1. Trihydride, tri means 3. Hydride, that would be hydrogen, so BH3. One other quick note here before I end the video. These prefixes here, you need to memorize these. Okay, it shouldn't take you too long to figure those out. Most of them you probably could figure out pretty quickly. Anyway, there's a few on there you might not be familiar with. So just going down the list: mono, di, tri, tetra, penta, hexa, hepta, octa. For 9, I've heard it pronounced with nona and nana, whatever your preference is, works great. And then deca.